Hi, I'm Mark Peltonen, President of StructSure. Today we're here at our Ogden, Utah manufacturing facility to talk about our patented hot wire cutting process. Today to introduce you to that would be Josh Lee. Hi Josh, how are you today?
Good, Mark, how are you doing?
Very good.
We have several components that we use to provide the patented process using a hot wire machine to cut into EPS foam a brace receiving slot. The main component is the table, which consists of the track and rails, the harp, the wires, and the computer system.
Josh, could you show us how these components operate?
Of course. Let me describe to you what they are. First of all is the table. This table is about 10 feet by 10 feet, so we can do some fairly decent sized blocks. Connected to the table is the harp, and that is connected by a rail and track system.
Okay.
Right here on this side. And again, we have the harp. The harp is the thing that does most of the work. Connected to the harp are the wires that move up and down in a y-axis.
Josh, could you explain the components here of what this would be?
This is a ruler scale that we use to manually set the distances between the wires. This is set at 4 inches. Connected to that is the electronics. To heat up the wire to about 120 degrees Celsius. It's just through resistance. You can see it actually cutting right now.
And Josh, how thick is this panel we're cutting right now?
This is a 4-inch panel that we're cutting right now. This will give us approximately R20 for our insulation.
Okay.
And how many men does it take to operate this table?
This table really only takes one person to run. At this panel, it's a 16-inch on center from notch to notch. That's what we programmed it in, so at every 16 inches it comes down and it makes our brace receiving slot. The computer runs the table. Here to talk about that is Sean Dorius. He's our plant manager here in Ogden, Utah.
Josh, what I do with this CAD program is I take a set of plans and I convert them into different profiles inside the program. And that program will send the message to the table to cut that profile. And in this program I have several files listed of walls that I've already designed, and it's as simple as clicking on a wall, loading the machine, and press and go.
How long would you say it takes you to program a profile?
It depends on the style of wall that it is. If it has lots of windows and doors, it obviously takes a little bit more time to enter all of the programs and all of the codes. It's fairly quick. Once you learn how to do it, you can program a wall in 15 to 20 minutes.
Perfect. After the panels are cut, they're laid out on the press table and studs are slid into them. Typically on a wall, we can run up to 20 feet long on one single wall. These studs are at 16-inch on center placement. After they're slid into place, then we take a track and put it on the bottom. Moving to this side, we put the opposite side track on. Close the gate. After the track is in place, then we shut the gate. Clear. As we were talking about before, the stud and the track, this gap has to be closed so the weight does not bear on the screw. Sean, go ahead and close that. The bearing weight on the structural wall cannot be resting on the screw. It has to be against the track to stud assembly.
This is where it all starts with our EPS foam, and you can see that this is pretty easy to move. It's light. Maybe give it a push. And what we use, and this goes onto our hot wire table, and we're able to cut our walls out of this. Chris, out of this billet, how many feet of wall can we get out of this?
You could easily cut. This is 4 by 4 by 8 feet, so you'd be looking at 32 feet of wall if you're 6 inches thick.
As you saw Mindy push this around, these are dollies that we make right here in our factory, along with the rest of our proprietary equipment as far as press tables, hot wire CNC cutting tables. We make all this equipment that provides the equipment for a complete factory, well, really for anywhere throughout the world.
Mark, can you tell me a little bit more about this wall? Is this a finished wall?
Yes, it is. This is actually a wall that we ship up to North Dakota for our hotels. And I would be standing, I'm on the interior of the home right now.
Okay.
And right here, you can see that we've got our interior wall, which is sheetrock,
okay,
and it's finished on the inside. You can't see that, but we are finished here. And here you've got your framing member. As you noticed when we were doing our demonstration for the cutting panel, this is our brace receiving slot.
Why doesn't this extend all the way through?
Well, this is to eliminate thermal bridging. And
Okay.
thermal bridging, if our stud was to go all the way out to the exterior wall, the cold or heat follows that into your interior wall.
Okay.
And with our brace receiving slot, we put a 2-inch buffer out here, which actually stops the thermal bridging because your framing member stops 2 inches before the actual exterior of the home.
So meaning for the customer, what does that mean?
Well, what that means is, simply is a 50% savings in energy.
Energy.
Yes.
Heating
So
and
that would be
cooling.
heating and cooling. Yes.
That's
Yeah,
pretty
it's
significant.
pretty amazing. And when we go to the exterior of the building, this right here is a true ethos system, which is a stucco system. Okay, very hard. And also with this type of building, you can put on brick, stone, siding, anything that goes on conventional construction can go on our wall as well.
Is all of this done in the warehouse?
Our stucco finishes are done within the warehouse, so this panel goes out just like this, ready to be put in, right up on site.
Is there any risk, because it is made out of foam, Mark, that I can punch through it?
I certainly wouldn't want to try doing it, no. It's a very sturdy building. These buildings are hurricane tested. They withstand winds up to 173 miles per hour. So it's a very strong.
So it's much sturdier than you think it would be?
Yes, yes. We have an interior finish, and we have your sheetrock or gypsum, which is here. And this is your steel framing member, or your stud. Here we have, it's still the piece of foam, but this is your exterior foam from your framing member. And out here is your finish, and on this building it is a true ethos system. And again, any other components can be used on there as well, brick, siding, stucco. These are our basement walls, and this is just the start of our basement walls. These don't have the finish on them yet,
Okay.
but these are for our foundation walls
Okay.
in your homes. And we will add our coatings on these, which is cementous coating that we put on these. And the only difference with this foam, as opposed to the foam that we would use on an interior wall or exterior wall, is our basement foam is a 2-pound foam.
Oh.
So it's a much denser, harder foam than our 1-pound foam.
And the advantage of that?
Just more strength for the basement, because when you have backfill that pushes against the basement wall, this it has a much stronger structural integrity than a 1-pound foam.
Wow.
Our associate Ron Langdana with Revolutionary Concrete Specialties out of Toronto, Canada, supplies this to us. It's a 2-part mixture that is elastomeric, and it seals the walls very nicely.